Dear student, today we are going to start a new topic, that is liquid state. In last class, we had knowledge about the solid state. Today I will explain you liquid state. So, dear student, let's start now with the very first point of liquid state. Dear student, in a liquid state of matter, particles are less tightly packed. Not very tightly, less tightly, okay, as compared to solid. As you know, what happens, suppose if you talk about the solid packing, okay, so this is any ball, metallic ball, okay, and this is any ball. So there is very less gap, or we can say negligible gap, between these two constituent particles. But in liquid, what happens actually, can you see some difference, okay, and in gas there is a huge difference. So what happens, in solid there is a tight packing of the constituent particles, but in liquid not tightly packed but not very loose packing, okay, it's just in between, the means just little bit far from as compared to the solid. So in a liquid state of matter, particles are less tightly packed as compared to solid. Dear student, let me talk you about the second point. Now liquids take the shape of the container in which they are kept. Yes, dear student, if you have one glass of water, okay, then the water has shape of glass, and if you take that water in any other container, okay, like if you take that glass of water in bowl, then it will take the shape of bowl. If you change the container, then shape will change. So liquid doesn't have any definite shape, but solids have definite shape only. If you put some solid material in glass, then the shape, whatever the shape of glass is, same shape you will find in bowl also, in plate also, in floor also, anywhere. But in case of liquid, the situation is different. It has no definite shape. So liquid takes the shape of the container in which they are kept. Let me tell you point number 3 now. Dear student, liquids are difficult to compress as particles have less space between them to move. No doubt. So actually what happens, in solids very difficult to compress, and in liquid also almost like solid situation only, they are also incompressible. You cannot compress. Have you ever tried to compress one glass of water? No, okay, but it doesn't mean that we can't compress, but generally liquids are incompressible like solids only. Let me give you the next point now. Dear student, liquids have fixed volume but no fixed shape. Yeah, liquids doesn't have shape because liquids have the shape of its container. But what about the volume? Volume is same. If suppose you have 1 liter milk in your mug, so 1 liter milk will be there if you keep it in bucket. 1 liter only milk will be. Milk is what? Just occupying capacity. If you talk about the volume, then in chemistry we define it like occupying capacity. In mathematics, volume is something different, that is different thing, but general terms, the volume means in chemistry occupying place, of occupying capacity, that is volume. So what happens in liquid, okay, volume is same whether it is in glass or in bowl or in bucket or in any other container. Let me tell you the next point now. The rate of diffusion in liquid is higher than that of solid. What is diffusion is the first thing. Then we will talk about the rate of diffusion about the solid. See, it is some kind of fluidity. Diffusion term I will explain after the gas. Okay, I will teach you a separate topic after gas, like I taught solid first, then I am teaching liquid, then I will teach in separate video gas, then I will explain about the diffusion of gas. Actually diffusion is very high in case of gas. What happens actually? What is diffusion? Diffusion is like reaching phenomena from one place to other place. Suppose any person used very good perfume in the classroom, or your teacher is using very good perfume, and when he or she enters in your classroom, you just try to identify, yes, this teacher used perfume, very good perfume, or sometime bad also. Okay, so what happened? How you came to know that this person used perfume or scent or deodorant? How you came to know that? The reason behind that is a diffusion phenomena. My dear student, what happened actually, the gas carried that perfume from your teacher's cloth into your nose actually, with the help of diffusion phenomena. So, in diffusion phenomena, what happens actually, traveling takes place and gas has very high rate of diffusion. And solid, suppose your teacher is bringing one mobile phone in his pocket. So, can you imagine that mobile phone will come from your teacher's pocket to your pocket? It is not possible, because solid has zero, means no diffusion at all. Okay. But what happens in case of gas, if your teacher is using that perfume, okay, then you will get that smell. You will surely get that smell will come to you. But whatever the mobile your teacher is using will never come to you in your pocket. And one more thing I want to say, if teacher is using very high amount of perfume and you are just very close to the teacher for large number of times, then maybe your cloth can also absorb that smell and you can also smell like your teacher only. So, all these phenomena is based on diffusion process, which is just like a carrier. I will make a separate video on the topic diffusion. My dear student, in the next point I will display now. Force of attraction between the particle is weaker than the solid. Yes, what happens actually? In solid, I told you, their constituent particles, they attract together with very large amount of force. They attract. Here also large amount of force, no problem, but not stronger like solid. Okay, here is also attraction between the constituent particles, but not stronger than the solid. It is little bit lesser than the solid. Dear student, now I will display the next point. Example of liquid state of matter. You know so many examples like water, milk, tea, coffee, blood, urine, so many things are there. They all are liquid only. Dear student, we have successfully completed our liquid states, and in the next video I will come with the gas. Thank you.